The next question, we have a uniform 4 kilogram solid disk of radius of r equal to 1 meter, and it is free to rotate on a frictionless horizontal axle, right? And we know that it's through its center, that this is initially at rest, so to take that into account. And then a 20 gram bullet traveling at 300 meters per second is fired into it as shown. If the bullet embeds itself in the disc at a vertical distance of 0.5 meters from the axle, what is the angular velocity of the disc? So we're looking at the angular velocity, and we know that our question is going to be in radians over seconds, right? Because it's angular. It's something you have to know. So if I have to draw you the diagram, it'll look like this. And then we have the bullet that's traveling across here, right? Well, it's traveling across here. So the bullet here. So now that we have that, let's start writing out our equation. So we know that we need to get this, right? Because MBR over 2, 20 times 10 to the third, negative third, 300, 1/2. That's our first thing we have to work with. The very, very first thing. And after we work it out, we know that the 30 to the 1/2 is going to really be 300 times 1/2 with this in conjunction is going to equal to 3, right? And we're going to break this essentially all down into this. So let me just write out the math so you can see what I'm doing. So the MB is equal to 20 times 10, 3 kgs, 10 times 10, k kilograms. And we also know the 1/2 times 12 equals 2 kilograms. That's right. So if we have that, we have to work on it, and you plug these in, right? So we'll essentially get 2 times 10 to negative kilogram, 2 kilogram times m squared, and then we'll get 3. So after you plug those in, we need to work now on this problem, the next part of the problem we're doing, and it's I equals to MBR squared over 4 plus JW. And we know that LI, right, is equal to 3. So since we know that LI is equal to 3, we can do this equation now, which is just going to be 3 over MB P2 over 4, right, plus J. Now we just have to plug in the numbers. So the numbers will be this numbers here. 2 times 10 to the negative 2 that we solved above, right? I showed you that we got the kilogram above. 4, and then plus 2. So now we have essentially all the numbers we need. This is the equation that we're going to use. And after you simplify it, the answer you're going to get is 1.5 rads per second, right? Because after you use the equation, you're going to realize like, oh, okay, that's how it's going to break down into. So just to show again, this was the equation we were able to work into. 2 times 10 to the negative squared plus 2, like this. And then this is going to equal to 1.5 rads after you do like your algebra and you work out a time. For example, like the 2 times 10 is going to equal to, it's really just 0.01 on top of your 4. But then you can just divide that, and it's going to change to your 2, and then you get your plus 2, and then you're over the 3, and that's just going to give you this answer. So the answer is C. Thank you.